Okay, let's dive into 1-2B, applications involving linear equations. And this section is going to be all about those special problems that you usually see on the SAT and the PSAT. This is going to separate you from those students that don't have this practice. So definitely worth trying some of these. This section, you're definitely going to want your calculators out. So grab your calculator and let's get going. So 1-2A, we worked on these two sections and we did a little bit of the interest problems. We're going to do one more of those today, and then we'll dive into mixture and distance rate time problems. Here we go. All right, so this first section here, multiple investments. What we're going to start with is this concept. Pretty straightforward when you first look at it. Part 1 plus part 2 equals total. The key is, remember from last time, we're only going to use one variable. I'm going to use X in this example. All right, so Teresa earns a full athletic scholarship for college, and her parents have given her the $20,000 they had saved to pay for her college tuition. Nice for her. All right, she decides to invest that money with an overall goal of earning 11% interest. So that's going to be our total. She's going to take $20,000 and invest it with 11% interest. So she's going to take her money and multiply it by 1.11. All right, so important to note, 11%, the same as 0.11 if we write it as a decimal, but we want to grow our money. We want to keep the original 20,000, so we actually have to multiply by 111% because we want to grow. 100% means what you had to start with plus an extra 11%. All right, so let's talk about what the different parts are. She wants to put some of her money in a low-risk investment that is earning 8% a year. All right, so we're going to take 8%, so 1.08, times how much? Sum of the money. We have no idea how much that is, so we're going to say X. All right, and the rest of the money, and here's the important thing, the rest is going to be total minus whatever you already used. So whatever we spent here is going to be taken away from the 20,000. So if we spent 5,000, we'd only have 15,000 left. If we spent 10,000, we'd have 10,000 left. And that's the amount that's going to be invested at 12% a year. We're going to add those two things together. So let's take a second to just look at what we're doing here. So we have some amount invested at 8%, and the rest at 12%. Now the rest is whatever's left over from the 20,000 that we didn't spend here. All right, so once we have the setup, fairly straightforward to just plug this into our calculator. 1.12 times 20,000 is 22,400 minus 1.12x plus 1.08x. And on the other side, we end up with 22,200. And so when we combine these together, we're going to get 22,400 minus 0.04x. And let's add, I'm sorry, not add, minus 22,400 to both sides. So we'll get negative 0.04x equals negative 200. And we can divide both sides by negative 0.04. We'll end up with x equals 5,000. All right, so we spent $5,000 at 8%, and the rest of it must have been at 12%. So you can see underneath here, 5,000 at 8, and the rest, 15,000 at 12%. All right, your turn. Give this a shot. All right, the setup on this one would be 24,000 times, oh, I'm sorry, we know the total. The total is going to be 27,480. And the 24,000 is split into two pots. So one at 18%, don't know how much, plus the rest, 12. So that's going to be 24,000 minus x. All right, let's put that into our calculator and see what we come up with. We'll get 1.18x plus 26,880 minus 1.12x equals 27,480. Let's subtract 26,880 And when we combine 18 minus 12, we get 0.06x equals 600 divided by 0.06. We get an x of 10,000. So we must have taken 10,000 at 18%. The rest, which would be 24,000 minus 10,000, which is 14,000 at 12%. Okay, next section we're going to get into our mixture problems. So just an example here. If we want to fill up on 89 octane gasoline, what we could do, if it was cheaper, is do some of 87 and some of 93 to mix it and end up with 89 at the end. So let's see an example here. The manual for your new car suggests using 89 octane. In order to save some money, decide to mix 87 and 93. But you already have some 89 already in the tank. All right. So you have 1 gallon of 89, plus you're going to add some 87 and 93 to achieve a mixture of 89. All right. So how are we going to do this? We're going to say, in this case, part 1 plus 2 plus part 3 equals the total. All right. So we know the total. What's the total going to be? The total is going to be 16 gallons of 89 octane. All right. So we can say 16 times 89. Let's think about what our parts are. We have 1 gallon from up here. Where was it? We already have 1 gallon of 89 in the tank, so we could say 1 times 89. Plus, part 2 is going to be some amount of 87. We're going to say 87 times x, plus the rest at 93. So 93, what's the rest? Well, it's going to be 15 gallons minus x, because we know we already used up 1 gallon of the 16-gallon tank. All right, so let's plug this in. 1 times 89 is 89, plus 87x, plus 93 times 15 is 1395, minus 93x, and that equals 1424 on the other side. So let's combine these together. 87 minus 93 is going to be negative 6x. And then we're going to have, on the other side, if we subtract away the 89 and the 1395, from 1424, we're going to end up with negative 60. That worked out nicely. X will be 10. So put this back into words. We need 10 gallons of 87, which means we must have 5 gallons of 93. Your turn. All right, to set this up correctly, we're going to have 100 milliliters of 11%. So we could say 11, or we could do 0.11. Either way, the math's going to work out the same. All right, so we have some amount at 15%, and the rest at 5%. So this is going to be 100 minus x, the rest left over. So 15x plus 500 minus 5x equals 1100. And so we're going to get 10x plus 500, 1100, 10x equals 600, x equals 60. We should have 60 milliliters at 15%, the rest, which would be 40 milliliters, at 5%. All right, on we go. Next section is going to be our distance, rate, time section. So the one thing we need to know for these is that distance is equal to rate times time. Got to remember that. Distance is rate times time. So it takes 8 hours to fly from Orlando to London and 9.5 hours to return. The thing to remember here is that the distance is the same both ways. If the airplane averages 550 miles per hour in still air, what's the average rate? So we got to find the rate of wind blowing in the direction from Orlando to London. All right, so if we agree that the distance from Orlando to London is the same as the distance from London to Orlando, then we can say rate times time should equal each other. But they're going to be different rates and different times. All right, so the rate on this first one, it took 8 hours to go from Orlando to London, and the rate here was 9.5 hours. All right. So now we got to figure out what the different rates are. So the rate going from Orlando to London was 550 miles per hour, plus we got some wind blowing in our direction. It made it faster for us. We're going to say 550 miles per hour plus x. Why plus x? Because we're going to say that the jet stream is pushing us, so we're actually going faster. But when we come back, we're going against that jet stream. So we have to take our miles per hour and say we're going to get slowed down. So that's your setup. Let's punch this in. 550 times 8 is 4,400 plus 8x equals 550 times 9.5 is 5225 minus 9.5x. And if we move these over, we'll get 17.5x equals 825. And so x, when we divide, is 47.14. So 47 miles per hour is the speed of the jet stream. Your turn. All right, let's set this up correctly. A Cessna 150, so the 150 is the number we're not actually going to use. Averages 150 miles per hour in still air. With a tailwind, it is able to make a trip in 2 1/3 hours. Because of the headwind, it is only able to make the return in 3.5 hours. So same setup. 150 plus our tailwind times 2 1/3 hours equals 150 minus x times 3.5 hours. Go ahead and solve for x. So I'm going to rewrite 2 1/3 as 7/3 times 150 plus x. I'm going to write 3.5 as 7/2 times 150 minus x. And we'll go ahead and solve. 7/3 times 150 is 350 plus 7/3x equals 525 minus 7/2x. And so if we put these together, we'll have 7/3x plus 7/2x equals 175. Get ourselves the common denominator on these, which would be 6. We go 2/2 and 3/3. And so we'll have 14 plus 21/6x, which is 35/6x equals 175. All right, how do we get rid of the 35/6? We multiply by 6/35 times 6/35, and we end up with an x of 30. Hopefully you agree. All right, last section, we're going to get our work problems. These are some problems that show up all the time on the PSAT and the SAT, and these problems are the most missed problems on the whole SAT. So let's figure out how to do them, and we can improve our scores. These are actually very simple to do if you know the formula. So Connie can clean her house in 2 hours. If Alvaro helps her, they can clean the house in 1 hour and 15 minutes together. How long would it take Alvaro to clean the house by himself? So here's how you need to do this. Okay, job over time plus job over time equals combined job over combined time. So let's talk about Connie. Connie can do 1 job in 2 hours. I'm going to write this as 120 minutes. Plus, Alvaro comes along and helps. He can do 1 job in, we don't know how long. So X minutes for Alvaro. But together, we know that they get 1 job done in 1 hour 15. So 1 hour 15 is 75 minutes. All right. Now, once we have this set up, it's fairly easy to solve for X. Let's find our common denominator. 120 times 75 is 9,000. We could probably find a smaller denominator, but we just multiply by 9,000. We'll cancel everything out. 9,000 divided by 120 is 75. X plus, our x's cancel out, 9,000 equals 75 divided into 9,000 is 120 with an x. Let's move the 75x over, and we end up with 45x. And when you divide 9,000 by 45, you end up with x equals 200. Now 3 hours is 180 minutes. So 200 is 3 hours and 20 minutes. That's how long it takes Alvaro to clean the house if he were doing it by himself. Which makes sense. He should be taking longer than the 2 hours that Connie took to do it. If he's helping her, it would go faster. All right, last one. Try it yourself. See if you can do it. All right, here's our setup. Christopher can do one job in 15 hours. Cynthia can do one job in we don't know how long, but together they get the job done in 9 hours. So our common denominator here is 135x. And so we'll end up with 9x plus 135 equals 18x. And so 135 is 6x divided by 6. And we end up with x equals 22.5. So Cynthia, working alone, would take 22.5 to get the job done. Good job. We'll see you in class.